means. This is a tough one. What does the word pair mean? Two. So we're gonna wrong pair. It's a parent you weren't reading. It was bad. We're gonna be talking about the relationship between two angles. Most of this, from what I understand, like all of it, is all review. For example, what is, do you remember the differences between complementary and supplementary angles? You're shaking your head. I bet you as soon as I say it, you will remember. How about this? I'm going to put you on the spot. You ready? This is a very tough question. I know you can do this. I have faith in you. Right? You're going to do this well. That was a bad high five. Come on. Come on! Come on! Don't you want a high five?
No.
All right, well, why are we missing a chair?
Because this one
That
was
one's
missing a
over
chair, so I took it.
Well, that chair's over there.
We had. Oh, it's hanging back there. Never mind. So here's what we got. You don't want to sit here. All right, so I'm looking at complementary and supplementary. It's a really tough question. I know you can do it. Is this, embarrassing yet? Not yet? All right, we can make it worse. All right. What comes first in the alphabet? Complementary or supplementary? You're thinking the ACDC in your head right now. What comes first in the alphabet? Complementary or supplementary? Complementary, she's right! All right. So, it's another real tough one. We're gonna go 2 for 2, okay? You're gonna double it down. What number comes first on the number line? 90 or 180? With authority.
90. I'll say quarter. 90.
No, it's
90.
90! So, now, am I getting there with the embarrassment part yet? Ish? How about the annoyance level? Is it like easy? Okay, good. I'm doing my job. So, what I'm saying here is, if I'm going to talk about complementary angles, I'm not just saying, you look very nice today. Not to look wrong, but it's not to give you a compliment.
There's a wall there now. I have to walk all the way around just because you have an extra student.
What was you? But what I'm saying
She
here
has
is,
to walk all the way around too.
do you guys? I just sit here all day. This is nice. What I'm saying here is that complementary angles are two angles that add up to equal 90. Supplementary angles would be two angles that add up to equal
180.
180. Get my hand on your mat. What? Jeez. I don't, can you?
Yeah.
Sure, I don't care. So complementary angles are two angles whose sum is 90. And yes, that is. I appreciate your willingness to put up with my annoyance. The correct answer was no, Mr. Murphy. You're not that annoying. You thought about saying it too. Now, two angles whose sum is 90 is complementary, and then two angles whose sum is 180 are supplementary. Does it say anything that the angles are next to each other? Nope, it just says two angles. That's it. Two angles who have a sum that equals 90, or two angles that have a sum equal to 180. The reason why I wanted to point out the fact that they don't necessarily have to be next to each other is because If you look on the back wall, we have a 60-degree angle. It's crazy, it's just there. I didn't know it was there, but it's there. So if I drew an angle here that was 30 degrees, aren't they complementary to one another? If I took those two angles and add them together, what do you get? 90. Okay? They don't have to be next to each other. Same deal, there's that 60. If I say that's 120, would those two be supplementary? Yeah. Or they could be right next to each other and still be supplementary. It just depends on how the thing is drawn. It depends on how they define it. Whether they are what we call adjacent or non-adjacent. You ever heard the word adjacent before? What is it? Yeah, exactly. Adjacent. So that's actually the next. It's convenient. The next one is adjacent. Nice segue there, huh? It's almost like I knew what I was doing. Like I said, there's this whole 85-15 thing where half the stuff I make up.
I don't even know. I don't know why.
It's nonsense.
She just doesn't.
Yeah.
That's all right, I don't like you either, so it's okay. That's why we get along. Adjacent angles. Adjacent angles are angles.
There's someone at the door.
Yeah, they'll be fine. I can't write.
I think she wants to learn.
I'm not walking on the playground.
Where is you? Where is you? So adjacent angles are angles that are
Walk home.
next to each other. More specifically, is she picking on you?
Yeah.
Why are you picking on her? This is not, no picking on zone.
You pick on us all the time. I didn't know less worth it.
Anyway, now more specifically, when you're talking about adjacent angles all share a common vertex and a side. Bless you. What I mean by this is that you guys, hi Benny! By all means, we're talking about adjacent angles.
Oh,
It's
they
ex-
lie next to each other.
Oh! I don't think they like my humor, Miss Denny.
Well, you know, I've had to be around for quite some time. It kind of grows on you.
Thanks, Miss
It's
Denny.
like this nasty thing that you want to have cut off.
Those are the doors with you. What?
Who is she?
That's Miss Denny. She's one of the math teachers.
She's a vet. I've never seen her. I've never seen her. What?
This year she's teaching stats, algebra 2, and honors pre-calc, I believe.
We can take that right now.
What's that?
All those classes you're using.
You can take them. I don't know if you would know what they were talking about, but yeah. Actually, the stats class you have your prerequisites is algebra 2. So, and then obviously honors pre-calc. You probably want to take honors algebra 2 to get to honors pre-calc. So remember all the problems you guys did yesterday with the algebra? Every single one of the problems you guys did yesterday kind of looked like this. Where you had A, B, C, D. Where you had the idea that angle ABC was made up of ABD and DBC, where they all shared that common vertex B. They all shared a common side, BD. Every problem you guys worked with yesterday were adjacent angles. They were angles that were next to each other. Not every single one of your problems you dealt with yesterday were adjacent complementary or adjacent supplementary, but every problem you did yesterday had something that looked like that, didn't it? So working with adjacent angles is nothing. That's how angle addition works. Two adjacent angles, two angles that are next to each other add up to equal a larger one. Done. What's going to be different today is that we can have adjacent complementary angles. Adjacent complementary angles are just two angles that are right next to each other that form a right angle. We can have non-adjacent complementary. Well, there's this one and then that one. They're not next to each other, they don't share a side, but they still add up to 90. So basically what I wanted to get with you guys on this is that if they're adjacent, they're next to each other. If they're not adjacent, they're not next to each other. It's that straightforward. Okay? Right? All right. Okay, what are these things? The next one that we go into then is actually two of them. First one is what we call a linear pair. Gee, what do you think linear stands for? Line. What do you think pair is dealing with? You say two. Bless you. Bless you. Two. Since we're talking about angles, if I say linear pair, I bet you might think I'm talking about two angles that form a, that's all it is. A linear pair are two adjacent angles that form a line. Two adjacent angles. Are you guys okay with me abbreviating adjacent with ADJ by now? I've done it twice. No one said anything. Well, it's not a beautiful angle. Yeah, you said adjective. That's an adjective, right? Beautiful. It's been a long. An angle. Right? So that's an adjective. Right. Beautiful being the strip. Yeah, I get. Wait. It's a acute angle. No. What do you mean? No. I know. I'll give him that one. So two adjacent angles whose sum. All right. That form a line. Their sum equals 180. Linear pairs are adjacent supplementary angles. It's I know I should be better at the degree, but at least you read it more than you knew it should be. Okay. Like I said, am I going to be heartbrokenly sorrowful and sad and shed a tear if you forget a degree symbol?
Yes. No.
Yes. No. No, it's really not simple. Okay.
In chemistry, I got 2 questions wrong because I didn't put a bar over 0 to make it significant. And I yelled at her about you. I said, he didn't mark it wrong. So
Well,
I gotta do it.
that's. Dang, we're not doing this now. Thanks. Oh, I'm such a jerk.
Not really.
Oh.
It's like,
All right. So, one of the ways we look at this is by using a lot of the definitions, and this kind of goes back to what geometry does to you. It makes you understand what everything means. Linear pairs are two angles that add up to equal 180. Those two angles just happen to be next to each other. We already defined that also as supplementary. But supplementary could be two angles that aren't next to each other. Linear pair is just a little bit more specific, that's all. You've dealt with it, you've done it, it's not going to be crazy. And I got a little chart we'll show you guys all the differences here in a second. And the very last one are what we call vertical angles. And this goes back to that the big diagram picture. We had the 162 in one spot, and we had to find all the different angles all the way around it. Honestly, I think the easiest way to talk about vertical angles is just to draw two lines. If I draw two lines, how many angles are formed when they intersect in one spot? 4. Very good. Everybody agrees that they see 4 angles here with the same vertex. So I'm just going to label them 1 little, 2 little, 3 little angles, 4. Is it? So I have 4 angles. But of those 4 angles, how many different angle degree measurements will I have? 2. Very good. I'm only going to have 2 of them. And the reason is, when you look at it, what do those 2 angles form? They form a line. What do these 2 angles form? I'm just looking at 2 and 3. They form a line. 3 and 4 form a line. So basically what happens here is the following. And I want to show you why this works. So don't write this part out here. Do you guys agree if I say angle 1 plus angle 2 is 180? And then if I say angle 2 plus angle 3, it's also equal to 180? All right. Now, last year you guys did stuff with this, with what's called systems of equations. Do you remember that? Solve for 2 variables with 2 equations? Oops. There we go. So what I want to do is write it like this. A plus B is 180. B plus C is 180. 2 variables, 2 equations. We okay with that? One of the methods that you guys did was that you guys set it up in terms of what's called substitution. Remember, substitution was just putting in something for something else? Watch what you can do here.
Should we write this down?
No, don't write this out. I'm trying to show you why this works. Is it okay by saying that angle B would equal 180 minus C? Just by moving that C value over in that second equation? What I'm doing here is using what's called a literal equation. Now, then I can take this and put it there. And I know you guys did this last year, because you had to have, because algebra classes all do this. So that means that A plus 180 minus C is 180. You okay with that? Putting something in for something else? Now, what happens when how do I move that negative C? How would you move a negative? You add it. So I get this A plus 180 is C plus 180. Now I have 180s on both sides. What happens if I subtract it out? Where do they go? They cancel out, right? So you get A equals C. That just shows you that in this diagram, if I relabel this as A, B, C, and D, that means that those 2 angles have to be the same. Vertical angles are angles that are opposite each other when 2 lines intersect. What I mean by opposite means they're across from each other. They're going opposite directions. Okay? They're not symmetrical.
Yeah.
Very similar, yeah, very similar. They'd be symmetrical about the vertex. They can flip over each other. Okay? And then also that means that if A and C are the same, what has to happen with B and D? They would also have to be the same. Now, someone asked me last hour, why did I put 2 arcs for those 2 and 1 arc for the smaller ones?
So you don't have to.
Very good. Because since there's going to be 2 different angle measures, like we did with segments, if you have different segment lengths, you can use multiple tick marks. Same thing with angles. You just use usually just use more arcs. That's it. All right. So vertical angles are angles that have a common vertex. Or let me rephrase this. Vertical angles, and this is what I want you to remember here. Vertical angles are angles formed when 2 lines intersect
So we're writing this down now?
at one point. they are congruent, opposite each other. The ones that are opposite each other are congruent. And that's what I want you guys to remember. And vertical angles are going to show up all the time. Yesterday we could have used them a lot to solve out that big pick, that 33 through 44 or whatever it was, those 6 questions off that. You had 3 different sets of vertical angles, and it was just really fast if we knew what that was already. Kind of surprised they would show that sooner. So vertical angles are formed when 2 lines intersect at one point, and they're congruent opposite each other. So whenever you have them across, the 2 angles that are opposite one another are always going to measure the same amount. Always. Okay. And that kind of gets us to the 4 different types of angles that we looked at for today. We have complementary angles. Their sum is how much? 90. Good. Supplementary angles. Their sum is very good, because C comes before S, and 90 comes before 180. It's stupid, but you'll remember it. Linear pair, what was their sum? How much? 180, yeah. Because line, remember lines are straight, silly, but 180. And then vertical angles. We don't have a sum for vertical angles, but what do we know about vertical angles? What are they equal? They equal each other. They equal each other. And maybe draw a little diagram like this with congruent here and here, and congruent here and here. That way you remember what it looks like, right? And that's kind of what we get at for today. It is these 4 quick definitions, but then being able to utilize them. And then an example. Gee, geometry and algebra goes right back to hand in hand again. All right. So in this example here, I look at the diagram. I look at what type of angle pair relationship we have, and then I decide, do I have to add these together to equal 180? Do I have to add them together to equal 90? Or do I set them equal to each other? And it's a matter of just reading and looking at the diagram to make that distinction. So we have angle ABD, angle DBC. Are those guys, just by looking at it, are they complementary, supplementary, linear pair, or vertical? Supplementary. Do you guys all agree that they form a line? So that means we can say that they're a linear pair. They're supplementary. So what do those 2 angles have to add up to equal? That's all it is, guys. You're not being told what to set it equal to. You have to decipher which one of these 4 that you're looking at. Once you do that, algebra goes real fast. So we have 4x plus 6 plus 11x minus 6 is 180. What's 4x and 11x? 15x, very good. What's 6 minus 6?
0.
0. So we get 15x is 180. Very good. Now, the question, remember, geometry is not always going to be plain old boring solve for x. It's also going to have a lot of substitute back in. So let's find each one of those 2 angles. Let's figure out what angle ABD and DBC is. What do you do to find out each individual angle? Yep, substitute back in. So if I substitute in there, I'm going to multiply it by 4. Remember, multiplying by 4 just means doubling it twice. So if I double 12, what do you get? Double it again, what do you get? What's 48 and 6? Very good. Then we have 11 times 12, which is the same thing as 10 times 12 plus 12, so it's 132. What's 132 subtract 6? Hey, do these two add up to equal 180? I hope so. If they don't, we know we done goofed. All right? That's about how, that's kind of how it goes, guys. It is going to be quite literally figure out which one of these you have that you're looking at and just solve. Okay? Notice the level of the algebra really isn't all that crazy. It's just what definition are you using? Same deal here. Go up so you can see it better. Same deal. What's a little bit different about this one, we have the one right angle, but how many angles are we looking at here in this case? 3 of them. There's 3 of them in this case. We're talking about linear pairs, complementaries, all that kind of stuff. That deals with how many angles? 2. So I need to do 1 of 2 things. Say, screw it, I'm not going to worry about linear pair stuff or angle pairs and look at what all 3 of those angles have to add up to equal. Or, what do those 2 angles on the side have to add up to equal? 90. Am I right either way? Yeah. What I'm getting at here, guys, is that knowing that that creates a line, I could add all 3 of those together to get 180. Or recognize you've already got 90 degrees here, which means how much is left for here? 90 degrees. And it's just the same stuff. Okay?
So either way you do it, it's right?
Yeah. Because watch what happens. If you go 2x plus 3x plus 90 equals 180, the first thing you're going to do is wind up with 5x equals 90. Isn't that the exact same thing as saying, hey, 2x plus 3x is going to equal 90? Same idea. Either way, you're going to wind up being just fine. So all you have to do is divide by 5. What do you get? You get 18. And then going back to substitute in, you'll find that you get, 36 and 54. And last I checked, those two should add up equal 90 degrees. Yay! Yay, math! Yay! No. All right, I got one more, and then I'll stop annoying you. Sometimes you're going to be given a problem where you have x's and y's, where you have to solve for both x and y. But you have to make the decision as far as which one are you going to go for first, and how are you going to set it up. So here, notice we've got 2 lines intersecting, which means when you have 2 lines intersecting, you're going to have vertical angles. Do you agree on that? So I know for certain that 6x minus 11 has to equal 20y plus 19. But since there's 2 variables, I can't do anything about it. So I have to try to work with one of the other parts. Well, the other part here is this 2x minus 9. So if I put these 2 together, what do they add up to equal? 180. They're a linear pair. They create a line. They're supplementary. So you do that step first. And then what? So we have 6x minus 11 and 2x minus 9 is 180. Well, what's 6x and 2x? Subtract 1. You get 8x, 200. How many quarters are in $2?
I
knew, no, because I knew it was 10.
There's 8 quarters and $2. Just making sure you guys knew that, right? There's 4 quarters and $1, and that means there's 8 and 2 of them. Making sure, it's kind of weird. So then if I have this, I can do one of two things. I can substitute X here. How much money is 6 quarters? $1.50. Take $1.50, subtract 11, you get $1.39. What's that? And the other one would be 50, subtract 9, you get, hey, good thing we did math right, because that those two add up to equal 180. So it's just a matter of, do I want to set this equal to 139, or do I want to add these two instead of equal to 180? Does it matter which one you do? Nope. But you're going to get the same result. And to be honest with you, using the vertical angles, it's one less step. That's all. So you just have to do just a little 2-step algebra problems here. And it works out really clean. It's no craziness at all. Okay? So if you have 20y plus 19 is 139. Subtract the 19. $1.20. Chop off the zeros, and what do you get? And there's your X and Y. Okay? It's just a matter of really which one are you working with. And that's the trick part. Identify what you're working with, and you guys will be good from there. Okay? I already posted the homework on the calendar. It's already up there. I'll show it to you, and I'll put it on the slide here for you. Let's see, today's Thursday. It's again back in the book. It is, what, page 39 this time?
Yes.
Just the next section over. In these problems, right here, in these problems, there are only 6 of them have the algebra. The other, I think there's 8 extra ones. The other 8 are, just what kind of angles are they? Are they vertical? Are they supplementary? Are they linear pair? Are they complementary? That's about it. And it's just by looking at the diagram and identifying the equal pair relationship. That won't take you very long whatsoever. Okay? Question? Tomorrow we'll do like I said, the last little bit of the algebra. My guess it should only take about 10 minutes to go over the algebra I want to show you, and then I'll just give you guys time to finish up the problems. I think I only have like 8 total problems for you guys tomorrow, so we'll be able to knock all that out in class. Go a little bit easier on the weekend, okay? Deal? I'll pull this up here in a second. You guys can get started on a couple of them because you have a few minutes to do so. Here's the first chunk of them, guys. Go ahead and get started on it so you can see them. Shh.
I love